Good afternoon, students. How was lunch today?
It was pretty good. How was yours?
Good. I saw your mama brought you some McDonald's.
Yeah.
That ain't fair. She didn't bring me none.
It's my birthday. I'm sorry.
Happy birthday. All right. All right, so we're taking roll. We're getting ready to go. Let's get on the roller coaster and learn today. You want to? All right. So can anybody tell me what we've been learning about?
Energy.
Energy, yes. And we're going to continue today talking about energy, but today we're going to focus on electrical energy. Okay? Y'all see, I've already put supplies out for you. So, but like I said, today we're going to focus on electrical energy. To start us off today, Levi, I'm going to play us a video, all right? I need everybody to pay attention, okay?
Electric charges can move easily through some objects, but not others. A material through which an electrical charge can move easily is called a conductor. Copper, gold, silver, and aluminum are some of the best conductors in the world. Many electric wires are made from copper and aluminum. A material that prevents the flow of an electric charge is called a resistor. In a resistor, electrical energy is converted to thermal energy. In toasters, wires of nickel and chromium act as resistors. This is why we can eat toasted bread. Strong types of resistors, called insulators, stop most electrical currents. Examples include rubber, plastic, and glass. In an electrical circuit, electricity flows through a circular path. Electricity can only flow if the circuit has no gaps that can interrupt the flow of electricity. A circuit of this type is called a closed circuit. Got it? Sure you do.
Got it? Good.
Sure we do.
All right, so like I said, we're talking about electrical energy. So electricity, what do we use electricity for?
To light up things.
Like the light in the room,
Mm-hmm.
plugging in your cell phones.
Yeah.
What else?
To plug in the stove.
The stove, the toaster, we saw it on there, huh?
Yes.
So electricity is important to us. So let's find out how it works, okay? So light was one of the things that we talked about. So today, we're going to make a series circuit, then show you how it lights up. So let's light it up. Everybody see this? All right, Lindsay, if you'll go shut the lights off for us real quick so we see this better.
Yes, sir.
As she's doing that, I want to talk about something real quick. Thing that you got to remember is electricity flows where, Levi? In a circle. Yeah, good job, in a circle. So as you can see, I have this set up here, and it lights up. Pretty cool, right?
Yes. That is very cool.
All right, so here a little bit later in the lessons, we're going to get to do this, but Levi, if you will go turn the lights on for us. As Levi's doing that, if y'all will open your journals, open to the page, the circuit lab. Okay, if everybody will open to that. All right, the first part of that sheet, the top of the sheet, the symbols for the circuits, okay? That's what we got to learn first. We got to talk about the symbols, and so you can identify the symbols. All right? What I've done, I've put them on the note cards. I will show them to you, and we'll talk about them, all right? As we talk about them on your paper, I'll show you the symbol, and you will write in what it is, okay? Does everybody understand that?
Yes, sir.
All right. You ready to get started? If you have trouble spelling, I do have the words written up here as we go through these, okay? To help some of you out if we need it. All right. Our first one is what? Can everybody see this?
Yes.
All right. What does it look like?
A wire.
A wire. It is a wire. All right. Wires. We have to have the conductor for the electricity to flow through. Remember that the wire inside is the conductor, but the plastic coating around is the insulator, okay? Wires up here, you write it in there. All right, so find that symbol on your paper and write it in right now, okay? All right, wires are very important. That's where the electricity runs through, okay? All right, everybody got that written down? All right, wire was the first one. All right, the next one we're going to talk about is this. What does that look like? It's funny, ain't it?
Yeah, I don't know what it looks like.
Levi, can you see this? What does that look like?
Electricity.
Well, it's actually a power source. This is your power source. Okay? And today, students, our power source that we're going to use here in the 5th grade class is a battery. That's going to be our power source. Yes, Lindsay,
What are some other power sources?
What are some other power sources? Electricity, like in the wall, is one. You know, not shooting out batteries, but you have different types of batteries, right? What about your car? How does your car run?
A battery.
A battery, right? Yeah. All right. Power source. All right, again, like I said, I have it up here if you need to help spelling it. If everybody will write that down on their piece of paper, we have a power source. All right, everybody see that? All right, good job. All right, the next word we're going to talk about is this. What does that look like?
Mountains.
Mountains. Anybody ever seen a TV show or you've been to the hospital to see a family member and the heart monitor's bouncing up and down?
Yeah,
That's what it looks like, right?
Yeah.
So, but this is actually called a resistor. So on your paper there, look for this symbol right here and write it down for me, okay? Good job. Resistor. Something that the electricity will travel through for the energy to change. Example, light bulb or a fan. Today, we're actually going to use a light bulb. That's going to be our source, Levi, a light bulb, all right? All right, good job, everybody. Y'all are doing a fantastic job. Remember, I have the words up here if you need to use them. All right, the next one that we're going to use is this. What does that symbol look like?
An X.
An X? What about the, like,
It's a power source.
actually, Levi, it's another symbol for resistor. It can represent any resistor. This one represents any resistor. Okay?
Oh, that makes sense.
This is also a symbol for resistor. So this symbol's on there too. If we write down resistor.
I have another question.
Okay. Yes.
What's the difference between the two?
Between the two, they're just different symbols. This one's actually universal. You can use it on any of them. Okay. Just different types. For example, this one right here. What does that look like, Lindsay?
A light bulb.
A light bulb. Everybody see that? Guess what? This is another symbol for a resistor.
Whoa.
So, and this is the one that we'll be working with today, but this is another symbol for a resistor. Like you said, there's different symbols for resistors. Okay? Another thing that we're going to talk about today is this. Everybody see that? Y'all see this in the back of the class? All right. What does that look like?
What does it look like, Levi?
It is a switch that.
It is hey. You're smart. You know that? Dang. Look at that. That is a switch. But what, okay, you're right. It's a switch. But what is it doing right there?
It's.
Is it open?
The energy.
Is it open or closed?
The energy stops whenever that opens.
Good job. You're right.
Yeah.
So it's an open switch like Levi said. And the energy can't flow through there because it's open. It's like a stop sign. It stops it, right?
Mm-hmm.
So if everybody will do this right here for me. Can y'all do this? So when we open it, energy can't flow through there, right? Okay? If you do this, look at this one, Levi. What is this?
It's a closed switch.
It's closed. So if you'll do this, it closes, right? And energy can flow all the way through.
That's like
Right?
this.
Just like Lindsay. See Lindsay's arms? If I took a ball or something and rolled it, I could go all the way around. But if Lindsay's arm was up like this, could I go all the way around? No, I'd have to stop, right?
It's just like a bridge.
It's a bridge. Good job.
But
Levi.
but it's like a one bridge. If it had two of them that were close to each other.
Good job. Hey, good job, man. You're so smart. Man, good job. All right, so we kind of got off there a little bit, but again, they're up here. I got the words spelled on the board if you need them. You need to find these two different y'all in the back of the class can see this. Y'all need to find these two different ones on your paper and write down which one's open. Lindsay, can you point to which one's open?
No.
All right, so this one's open. Levi, which one's closed?
That one.
That one. Yeah, good job.
Yeah, two of them.
Yeah.
It's
All right.
bridge.
All right, good job. So those are our symbols. That's what we've learned today. All right, but let's talk about it just a little bit more before we go to our activity, okay? So, Lindsay. Actually, yeah, Lindsay, what is this symbol?
A power source.
And we just wrote that down, right? What power source are we using today?
A battery.
A battery. And you asked a question earlier, but what other power sources are there? Can you name me another one?
Electricity.
Like in the wall, right?
Yes.
Plug it in. Good job. Okay, so, Levi, in order to make this electricity go, what do we have to do here? What do we have to have?
Make a circle.
Make a circle. Why?
Because that's what you always have to do.
Because the electricity flows through, right? All the way through, right? Okay, let me ask you this question. This is what we have up here right now, right? Is electricity flowing through there?
Yes.
Okay, but can we tell? Is there any way we can tell?
Yes, because it's going like.
Hey, good try, Levi. That was a good try, but no, we can't tell because we don't have a resistor, right?
Yeah.
And remember what I said? We have to use a resistor like a light bulb, a fan.
It's kind of like an apple.
Yeah, good job. Go ahead and sit down for me, Levi. You're doing a good job, all right? Hang in there with me. All right, so the electricity's flowing through here, but we can't tell that it is because we got to put a resistor in there. For example, would a toaster be a resistor?
Yes.
Yeah, because it makes it work.
But
But, hang on. But we're going to use a light bulb, right? So if we put a light bulb in here, now, could we tell if it works or not?
it's
No,
not-
hey, please don't touch none of the equipment yet, okay? You're doing a good job. All right, so if we come through here, electricity goes through here, and the light bulb lights up, right? Then we know it works. It's a resistor. Okay, Levi, what happens if we put two of them in here? Would they both work, or just one work, or neither one work, or?
Both work.
Both work, right? We can add as many as we want here, right? The one thing we got to remember, though, is our power source has got to be able to handle that. Okay, we got to have big enough power source to handle it, to push the electricity
You
through.
have to have a bigger one to have
Right.
three of them.
So, we have let me ask you this, Lindsay. Say this light bulb quits working. Will this one still work?
No.
No.
Why?
Because there's a hole now.
Because it stops the flow, right?
Yes.
Just like this. Let's talk about this. Levi did a good job explaining this. But if we have a switch in there, and it looks like that, what is that? Again, Lindsay?
It's an open one.
Open switch, yeah. I asked Lindsay to answer, but good job, Levi. You're doing a good job. All right, so if I have an open switch, Levi, will these lights work?
No.
No, why?
Because it's like that and it will go like.
Because the electricity won't flow all the way around. So what do we have to do here with the switch?
We have to close
Close it.
We got to close it. So just like that, right?
Yeah.
So do we understand now?
Yes.
What does electricity do? Flows in a
Circle.
circle. All right, something I didn't say though. Electricity flows from where? So y'all know what this symbol means, right? That's a positive, and that's a negative. Y'all learned that in math class, right?
Yes.
So when we do this, electricity flows where? Negative to positive, right? So we got to remember that. Negative, positive. Guys, y'all are doing a great job. I'm proud of every one of y'all today. Y'all are listening. Levi, man, you're answering a lot of questions. You normally don't, but you're doing a good job today. All right, so when I tell you, I'm going to have you take the equipment out. We're going to get to do the experiment now. Y'all ready to line it up?
Yeah.
Yeah, it looks fun. Let's not touch anything yet. As I tell you, though, I'm going to get you to to get things out one at a time, all right? You're going to work in groups. Like I said earlier in the class, I've already put all your supplies on your table just to kind of save us some time so we can get through this today, all right? All right. So, first thing, I want everybody to grab one yellow thing out of your table. Out of your bucket, sorry. All right, just take this out. Set it down on your table. All right, what do you think that thing is? What's it made of?
Plastic.
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 So plastic is what?
A conductor.
No, it's an insulator.
Oh.
Not yet, Levi. Calm down. Hang on just 1 minute, all right? All right, so we have an insulator, okay? I want you to set your insulator down. Next thing I want you to grab is the battery. Everybody grab a battery. Okay, we talked about positive and negative, right? Positive and negative. I want you to identify your positive side. What's the symbol for positive again?
A plus.
A plus. So I want you to locate that plus sign. Can everybody see that?
Yes, sir.
All right, good job. Levi, do you know where your plus sign is? Can you show it to me on there? Good job. All right, we want that up so we can see where that's at, all right? I want you to lay them in your insulators just like that. Next thing I want you to grab, I want everybody to grab 2 clips. Okay. I want you to see this. This clip has a clip on the outside. Do you see that?
Yeah.
Okay, I want you to put that on the outside just like I'm doing. See how I'm doing this?
Yes, sir.
Okay, I want you to put this clip in there just like that. With the clip showing on the outside, and then on the negative side, do the same exact thing. Okay? All right, and then I want you to line your batteries up just like mine. Can everybody do that?
Mm-hmm.
Levi, can you do that? Hey, put your batteries.
Like that.
Okay. All right, the next thing I need you to do is get your light bulb and 2 wires.
One wire, 2 wire.
All right. I need you to connect a wire to each side of the light bulb.
Wait. No, not yet. No.
Yeah, you're doing a good job, Levi. Connect it here first. Yeah, good job, good job. All right, now we're going to connect one to a negative, one to a positive. Why?
Because it's positive to negative.
Negative to positive.
Negative to positive.
So you hook up your negative and you hook up your positive, just like that. And I'll show y'all on mine, just like y'all are doing y'all's. So, there you go. And positive. Okay, next thing I need you to do is take your last wire out. Okay? Alright. Now I need you to connect the positive to the negative again. And look at me, I goofed. Yeah, I'm not paying attention. Y'all are paying more attention to me. I put my batteries backwards. So you need to make sure you do it right. Because if you don't, what happens?
It doesn't work.
It won't work, right?
Whoa.
So let me retry this on mine.
Look, do yours again?
And just like that.
Whoa.
All right. Looks pretty cool, right? Let me turn off the lights again. Look at all these lights lit up. That's pretty cool, right?
Yeah.
Yeah.
Do you know what else we can do?
What else can we do, Levi?
We can do this.
What's that?
Keep it closed and
And hold it up to it.
Yeah.
yeah.
But let me ask you a question. So plug yours back in. And I want y'all to watch Levi here. How's the electricity flowing here?
Can you trace it? Here.
How's it? Trace the electricity for me. How's it going? In a
Circle.
good job, buddy. Man, you are smart. All right. Y'all don't have this equipment on your table, but I'm just going to show y'all something really cool real quick. Because we talked about this, right? We talked about what, Levi?
The switch.
The switch. And you compared it like a bridge. Good job.
If
Hey,
we-
will you come assist me up here?
Mhm.
All right, good. All right, so we have a switch. You see that?
Yeah,
have
we
it open.
had
Hang
two
on,
ones
hang on.
and
So we're going to connect it just like this, right? All right. Then we'll connect this one to the positive side. And then we need another wire, right? And then we're going to connect it here, like this. Can I ask you a question? Look at it. Is it working?
No.
Why is it not working, Levi?
Because it has to be like...
It has to be what? Closed. Now it's working. Yeah. Hey, can anybody... All right, you can go sit down. Hey, good job. Hey, thanks. Hey, I'll get you a sticker for your sticker box, all right?
Okay.
For helping me out. Good job. All right. Let me ask you another question. This is a switch, right?
Yes.
Okay. Can you think of any other switches we might use?
A light switch.
A light switch. Hey, what about, we were talking about electricity. What about a car? Is there a switch in a car? When you turn it on and on, right? That's another, yeah,
It's
the
just
ignition.
like, it's just like this.
Yeah. All right, go sit down,
Or
right?
it could be like...
All right, let's talk about one other thing here, all right? Y'all see how bright those lights were?
Yes.
Pretty bright, right?
Yeah.
Because we had 2 power sources going through.
With one light bulb.
Let me show you this. Lindsay, will you go shut the lights off one more time?
Yes, sir. One's kind of not working.
They're not as bright as like y'all's. Look at y'all's. Y'all see y'all's? And y'all see mine? All right, can y'all explain to me, why do you think it's not as bright?
Because it's taking up more.
It's taking up more power, right?
Mhm.
So what can we do?
We can put it in the
We could put in another battery and add another power source, right? It's a good job. All right. All right. Hey, that was pretty fun, wasn't it?
Yes.
Y'all got to do an experiment and everything. Everybody's done a really good job. As y'all do that, I need you to go ahead and take or leave your circuits out. Okay? You got your circuits out?
Yes, sir.
All right. All right. I need you to leave them out, okay? All right. At the bottom of your page, everybody see your page here? Okay. I need you to draw what I just drew. But hang on. I want you to draw your circuit. The one you made, okay? That way you can remember it forever. So put in how many, what in there? Remember, hey, let me ask you this question again. Levi, what is this right here?
A power source.
Power source, good job. Lindsay, what's this?
A resistor.
A resistor. So when you draw yours, how are you going to draw yours?
With two power sources and a resistor.
2 power sources and a resistor. Good job.
I'm gonna do it like that, like.
No, I need you to draw like yours. I need you to draw like yours, all right? That's what you'll draw. Okay? All right. Do y'all have any questions before we get started?
No, sir.
Does everybody understand the way the electricity flows?
Yes, sir.
That's another form of energy, right? And what have we been talking about?
Energy.
All right. All right, y'all get started there. I'll come around and check on y'all.